Guys, you're welcome to my channel. I've received a lot of questions regarding electricity practical, and I'm here now to take us through how to go about it. The major problem with electricity practical is two things. Number one, for you to know the theory that you want to prove. Why do you need to know the theory you want to prove? So that you'll be able to know if the reading that you are getting is intact or not. What do I mean? You know, when you are taking reading on ammeter and voltmeter, you want to know if that reading, if the theory you are verifying says that if the current on ammeter increase, then the voltage current must have also increased. If the ammeter current decrease, the voltage current must have also decrease. If that is what the theory is all about, you'll be able to know from the value that you are picking. Are you getting this now? And if the theory that you are trying to work out is that as ammeter is reading a very low current, voltmeter should be increasing. Are you getting this now? Please, I want you to listen to me with an open mind. I'm just telling you possibility of things, because somebody will be like, it's not Ohm's law. When voltage increase, current should also increase. The case is not always like that. We can prove Ohm's law in different cases. Are you getting it now? So, for example, if the circuit arrangement is such that the kind of current you are getting is an inverse current, that is I raised to power minus 1. If that is what you are getting, then whenever voltage is increasing, current has to be decreasing if it is actually correct. So, what if the arrangement of the circuit shows that, what's it called, the voltage is inverse? You will not know because you've not been doing experiments back and forth. You only know the theoretical part. So you need to understand very well why the examiner asks us to use meter bridge, why rheostat, why resistance box. When you know that rheostat is also a resistance on its own, then we have another constant resistance. We have another resistance again. How come? And even the wire, the Constantine wire that you have on your meter bridge is also having its own resistance. So we now have enough resistance now. What is happening? Are this resistance still the same thing as V equal RI? Is it still the same thing as that, or what? You can't really tell until you understand the experiment very well. So when you understand the experiment very well, that is theoretical background of it, in how many ways can we express Ohm's law? Because most of us, the only way we know to express Ohm's law is V equal IR. Is that the only way of expressing Ohm's law? No. I can express Ohm's law as V equal to what? R all over what? I inverse. It's still the same thing as what you said earlier. You see, V equal what? R over I inverse. I inverse multiplied by what? R. Is still the same thing as what? What you are talking about? I believe somebody did not get what I'm saying. This is what I'm saying here. Can you move closer, please? You know, if I have my current, move closer so that it can be shown. So, if I have that V equal to IR, this is Ohm's law, right? I can express this as saying that V equal to R all over I inverse. Can you see this now? So, I inverse, if I say, okay, 1 all over I inverse is the same thing as what? I. You see the way I express this mathematically in this format. The same thing is what examiner is doing whenever they scattered apparatus like that. Normally, if I'm to verify Ohm's law, it's enough for me to have what? Voltage, that is voltmeter, ammeter, myself, my rheostat, and my key. So all of this, they are enough for me to prove Ohm's law. But it's so direct, it's predictable, because if I do ammeter, voltmeter, key, cell, and then rheostat, if I do that, I know that when current is increasing, voltage will also be what? Increasing. So that is very easy for me to predict. And no job or any difficult stuff will be done. So examiner want it to be experiment. They don't want it to be a manipulated stuff. Do you understand that now? Though I'll still talk about the manipulated part of this experiment, but get this first before anything what? Anything manipulation. And I hope this set us well. The second thing that I want to point out is that a lot of YouTubers, and I want to tell you something, YouTubers are not Lord. We might just be good, are you getting this now, and be confident of what we know. If that is the reason why we are coming here, then it's fine, but we are human, we can make mistake, we can say rubbish. At times we are under pressure of time. For example, my necklace experiment, I said it personally that my counting of oscillation is not accurate. That's not how it's supposed to be. But why is it like that? Because I'm paying for time. So I need to get what I want to do faster before the time. So you look at that. So if a student does come and watch, who does not understand the counting of oscillation, such student will count the same way I counted. And the same thing goes to other YouTubers also. For example, this electricity, I've seen a lot of YouTubers who are not doing it right. Like they are solving questions that does not even relate to this particular setup. For example, a YouTuber using galvanometer when there's no galvanometer here. Why galvanometer? Because there is already pressure of creating a video on this experiment. So they thought that it's not possible, maybe WAEC forget to put it. It's not compulsory that I want to use a meter bridge, then I should use galvanometer. It's not a compulsory. Are you getting this now? I'll talk about galvanometer in my other videos, explaining all those apparatus for you, so that you know reason why we use them when we use them. Are you getting it now? So, because I could see on some people's, on some YouTuber comment section, whereby they are being challenged. And I want to tell you guys something. If you're a YouTuber and you're watching this, please, let's be open to correction. All people that are watching our video, they are not all novice. We have a lot of them that are very good than we do. But just because they still want to be good better, they just want to take information from us. So when they call our attention to something, open-minded, listen to them. When they are wrong, point out why they are wrong. When they are correct, admit and what? Make correction. That will make us better. It is their comment, their complaint that make us better. So telling them that there's no way you're going to use meter bridge and you're not going to use galvanometer, I'm very sorry, you are not correct with that statement. You can use what? Meter bridge without galvanometer. I hope that is clear now. Okay, so let's go into the main question for today. Now, when you look at the question that I have here, I've tried to sketch this diagram in two ways, and I must give credit to a colleague of mine, Lawson. I don't know if you are watching this right now. I so much appreciate you. Lawson come through with the first diagram that you are seeing here. Please, can you move closer and show it clearly? Yeah, can you see? This circuit diagram you are seeing here, I got it yesterday from a very good colleague of mine, Lawson, and when I see this, it makes sense. But what's the difference between this diagram and the one he showed is that in the one he showed, they utilize what? Potentiometer. So I just replaced the potentiometer with what? Meter bridge. Can you see this now? Then, this same circuit diagram, I decided to show you that it can also come in this manner. Are you seeing it now? So this one is very, very possible for you to see this. Are you seeing? But it is still saying what? The same thing. When you look at it here, resistance is parallel to voltage here. When you look at it here, also the same thing. You cannot connect voltage in series. Please note that, because I heard a lot of people saying that okay, voltage is low. Voltage should be in parallel, because when you arrange resistors in parallel, the same voltage flow through them. Are you getting this now? That's why this one will always be in what? In parallel. And your ammeter will always be in series. Why? Because the same current flow through them when they are in series. Are you getting the reason why all these things are always positioned this way? Because I don't want you to just come here and just take any information dogmatically. You need to understand whatever you are taking home. Am I clear? So please take note of that. So we are going to be referring to this circuit diagram here to understand our setup. So I'm going to set the apparatus up, and you see the way it goes. I don't know if time permits us, we are going to carry out everything completely. But otherwise, wherever the time stops for me, I'll stop there. Are you getting it? So, and that's why I'm requesting for you guys support on this channel. Somebody just supported us this afternoon with a 5,000 naira, and I really appreciate the person very much. If you are watching this, I don't know your name, but I'm saying it sincerely. We appreciate, and that's the reason why we could do this video. Seriously. Okay, so we are running out of time already, so let's get started. Whenever you want to do experiments on electricity, the first thing you want to be sure about is that all your apparatus are intact, especially the apparatus that wants to read voltage and what current. And how do you check that? So this is your cell, this is an accumulator now. We are asked to use a 2-volt battery. Are you getting it now? So accumulator can only give you 2 volts, and this is what we have here. So this is a positive pole. Can you move closer please so that they can see that clearly? This is the positive pole of this battery, and this is the negative pole. So I'm connecting the positive pole of the battery to the positive pole of the voltmeter first. I want to check if I want to know the voltage of the battery, and I want to know if my voltmeter is actually working. That's the first thing you need to check. Very important. So then attach this one to the negative pole of the battery. So that's the first thing you want to do. Move closer and let them see. You can see that the voltmeter read what? 2 volts. Are you seeing it now? That's the what? The voltage of the battery. Can you move closer so that I can show them? Can you see? This is the voltage of the battery, 2 volts. Okay, so if that is cleared, check the ammeter also. So let's check the ammeter. So you pick the ammeter, then connect the positive pole of the ammeter with the positive pole of the battery also to check if the ammeter is also functioning. So connect it together like this, then pick the negative pole of the battery, connect it to the negative pole of the ammeter, and let's see if it deflects. Okay, I think I'm making a mistake now. Oh, sorry. You see what happened right now? I'm picking the negative pole of the ammeter, so there's mistake in the pole, and that's why you see that it goes on the wrong side. So I hope you learned something there. So this is supposed to be like this. So positive to positive, and then negative to negative. So can you see now? So that means the 2-volt battery produces a current of now I want to quickly explain something here. You have 2 values here. It's possible you are using this kind of ammeter. There's 2 values here. You have a value down here, and you have a value at the top here. You see the value at the down part here? That's for if you connect this positive pole to this 5 ampere here. So that's when you use the value you have at the down part here. But if you connect the positive pole to this 3 volts that I have here, it's going to be reading the one at the top here. Can you see? So is 0 to what? 0.6 ampere. So that means the 2-volt battery give us a current of what? Is 0.6 ampere. That's the maximum current you can have. Am I making sense now? Okay, so we are sure now that our what is it called is working, our ammeter is working, and our voltmeter is also working. So what's the next thing you need to do? The first thing you now need to do now is that all the terminals of your apparatus connect wire to their terminals. You see, move closer. The 2 terminal here, you can see wire there. The 2 terminal here, you see the connecting wire there already. The terminal here, you see the connecting wire there already. The terminal here, you see the connecting wire, and the terminal here also connecting wire. You see that of the ammeter, the connecting wire is there. You see that of the battery, the connecting wire is there. That of rheostat. Now I need to explain something to you about the rheostat. Somebody commented the last time I was explaining about this electricity, and the person said that you are not to connect the 2 down part of the rheostat, that is supposed to connect 1 down part and 1 top part. Now I want to say something. When you want to learn something, don't just learn it because somebody do it. Understand reason why the person did it. If you don't understand, if it is a video like this one you are watching, comment and ask that question. Are you getting this now? There will be response so that you understand why we do what we do. You can use these 2 points here. Are you getting me now? Or you use one of this and one of this. Any of it will give you reading. Am I making sense? It's your choice. Either you use these 2 or you use one of this and one of this. You are fine to go. Am I making sense now? So the 2 will give you results. Is that taken? So please, that's that about that. So I've connected 1 to this place and 1 to this place also. Why do I do that? I know somebody is about to ask that. I did that because most times I don't always have time to respond to some comments. And if you drop a critique comment, if I did not respond faster, you might think I'm trying to avoid you. So that's why I always try to make sure that I avoid a lot of controversy whenever I'm doing these things. So that's why I just choose this one and this one, since that is what generally everybody knows. Is that taken now? All right. So it's only voltmeter that I'm yet to put what is it called on connecting wire. And please look at the kind of connecting wire I'm using. I'm using black and white because this black and red. This kind of connecting wire is good for your health. Are you getting it now? So don't use some other ones that their resistance is high or they can cut easily. So this one is very okay. So don't let us waste much time. Let's go on now. Now, how do we start connecting? You can see now all this line that you are seeing, in this circuit diagram, they represent connecting wires. Am I making sense now? So we have that a wire that goes to the base of a resistance. Are you getting it now? The same wire goes to another terminal on a meter bridge, because this is a meter bridge now. Can you see? So we connect what resistance to the meter bridge and the resistance box to the meter bridge as well. So you can see I'm picking this now. So connect this to this. So can you see this now? All right. So we have this right now. Okay. So pick this also and connect to this. Hope you are seeing this clearly. Okay, so we are done with this now. So if you look at the other side here, you have resistance box, which is what we have here. So I connect my resistance box here. So there are a lot of style of resistance box. I don't know the one you have in your school, but this is the one we have where I am. Right? So I take this here. Okay, so this is fine like this. I see it now. So I have this, I have this. So what next? Look at this diagram now. You see that the voltage is what is parallel to this resistance. So this is my voltmeter. Can you see? This is my resistance, 1 ohm resistance. You know, they are going to cover this one for you. You don't know that it is 1 ohm, but it is 1 ohm. Is that taken now? In case you want to manipulate. Okay, so take now from one end of the terminal, take it down to this place, to the positive pole of the voltmeter. Oh, good. Then the other terminal here, you take it to the negative pole of the voltmeter, like this. Okay, so we're done with that also. So if you look at our diagram now, we are in line. So what next? What next right now is for us now to connect what the meter bridge to the key. Okay. So if you look at this now, this is the key here, and it goes to the end of this meter bridge here. So I have this. Like I told you earlier, you're having the same thing with this. I think this is quite clear enough for you to understand. So can you see? Okay, so you can see what I have here. Can you see? This is what the meter bridge. Look at the terminal here coming down to the key. So I connect this like this. Then the next one, you have this now connected to the negative pole of the ammeter. Can you see this now? So I have this now. Then I have the next one, which is positive pole of the ammeter. Okay, sorry. The negative pole of the key goes to one leg of the ammeter. Sorry, that will be the positive pole of the ammeter. Do you know why? Because if you look at this ammeter here, it's connected to negative pole here. Are you getting it now? So negative pole of ammeter needs to go to negative pole of the battery. So pick the negative pole of the ammeter and let it go to the negative pole of the battery. So that means the other leg of the ammeter that goes to the key is the right, that is the positive pole of the ammeter. Can somebody help me with my hanky so that I can clean my sweat? So the positive pole of the battery of the ammeter goes to one leg of the key rather. All right. So can you see this now? So the next thing is that what? The positive pole of the battery. This long one is the positive pole of the battery. Please note it very well. So you pick the what? The positive pole of the battery goes to one leg of the rheostat, just like I have it here right now. Okay, so can you see this now? All right, so another leg of the rheostat goes to the what? Goes to the meter bridge. You can see that. Please show the cycle so that they can easily follow the circuit up. So you connect it like this. So you have nothing to fear. Just connect exactly the way you see it. Can you see? Rheostat. Can you see? Rheostat, battery, ammeter, key. Can you see? Then meter bridge. Can you see the meter bridge right here? Then we have what? The 1 ohms resistor, that is unknown resistor. Can you see? Resistance box and the voltmeter. Now, what's the next thing to do? Then we have our jockey. So the center here is connected to the what? Jockey. So connected to the jockey. I hope it's clear, right? Okay, because I would like to avoid that question of. Okay, so now we have our circuit connected. Now, if you are using this meter bridge, there's something I want you to note. Come, move closer. Let me show them this, because it's. Can you see? If you don't have this iron here, the circuit will not give you the right thing, or it might not work, because it is this iron that connects this place and this place together that make them work as a circuit. Why this iron is not there? This place has been disconnected, this place has been disconnected. And that is the case of using meter bridge as potentiometer. I once said it that you can convert your meter bridge to potentiometer. How do you do that? Just remove this iron. Move closer, or is it capturing it? You can just, once you remove this iron, this place will be functioning as potentiometer. Once you put the iron back, it functions as a meter bridge. You have the iron at both ends. Now let's take for instance that your school did not have, like the meter bridge represents you did not have this iron. You can have a conductor to connect this side and this side together. You can use a connecting wire to do that. Am I making sense now? Okay? So what's the next thing? Let's go to the question now. And what does the question state? The question states that okay, connect the circuits as shown in the diagram above. Adjust the rheostat such that when the jockey is at G, that is when the jockey is at G, which is 0.0 of the meter bridge. Are you getting it now? The ammeter shows maximum deflection. Now, when the jockey is at G, it's as if you don't use the jockey at all. So, how do you go about that? Then, make sure you close your circuits. That is, you have switched your circuits on like this. Now, let us look at, come closer. So, we now adjust our rheostat. And we look up, we need to adjust our rheostat now. You see that, move closer so that you can see the reading on the ammeter. So when I start adjusting my rheostat now, you can see this is on 0.0 now. So if I adjust my rheostat, you see, my current is reducing that way, right? So I want the current to increase. So I adjust the rheostat this way. Please show the way I'm adjusting the rheostat. So if I'm adjusting it like this, you just see that the current is now what? Increasing. So, can you see now? So, let's see, there's another region where we are going to have a maximum current. No other region. So, let's go back to that region where it deflects maximally. So, let's just keep checking. Vary the rheostat till you have that point back. So the point should be somewhere here. Okay, we're not having it. Okay. I think it's at this point right now. So move closer so that the reading can show. Can you see now? So what did they ask us to do at this point? Can you see what we have now? So what exactly did they ask us to do next? Okay, read and record the value of the current I0. keeping the rheostat fixed in this position throughout the experiment, put the jockey at T such that 15 centimeter, read and record the corresponding readings of the ammeter I and the voltmeter V. So right now we are going to take down this reading of ammeter, that is this maximum reading. We need to take it down. So when we take it down, we now start the experiment by doing what they ask us to do, taking correct. You are not touching the rheostat again. And I quickly want to explain something here. You see that this experiment say we should leave the rheostat constant like that, right? The experiment can come in another way and ask us to leave T to be constant. That is, always place your jockey at a particular length while you vary your rheostat. Are you getting it now? It's possible. The experiment can come back, keep your current, keep it constant. Are you getting it now? That is, move your rheostat until the current gets to a particular level. So measure the length of this wire then, that is, vary your jockey and know where it is then, and also take the reading on the voltmeter. Am I making sense now? So a lot of things can be kept constant. Like now we are keeping rheostat constant. At times it can be the voltmeter that are going to, it can be the ammeter, that is the current that you will keep constant depending on how the question comes. But you know, this one now, we said we should keep what? Rheostat constant. Now we are going to start by setting the value for the resistance box, start picking some value for it, and with that we are going to come up with a successful experiment. So right now I will have to stop here. So if you have a question, you can let me know in the comment section, and if you would like to have these questions, you can chat me up on WhatsApp so that you can have a picture of it. And by tomorrow, if I'm chanced, I'm going to come up with theoretical explanation of this experiment so that if you want to manipulate, then you can get something done. See you in the next one.